Okay, we are going to start today's lesson about multiplying and dividing rationals with some really familiar, simple problems. If we go back to the basics, and I say 1/2 times 3/4, we very quickly and very easily write 3/8, and we don't even think about the process we went through to do it. If I give you an example like 1/2 times 4/7, we also quickly go through that example of saying, well, cancel, cancel, and we end up with 2/7, and we call it done. That is going to be the exact same process we are going to go through, except now we are going to have expressions with quantities that are going to be our canceling elements. If you remember back to the days when you needed to divide fractions, remember there was a quick and easy process where we learned we just multiplied by the reciprocal. And now it's a multiplication process. We cancel, and we come up with 2/3. That is all there is to today's lessons, variables or not. So, summary, when you're multiplying rational expressions, you are taking the numerator times the numerator, the denominator times the denominator, and you're going to simplify, cancel, and factor to get it into lowest terms. So if we look at our first example, very straightforward. It's all multiplication. We can think about this as being a single fraction, which I find helpful. We may cancel anywhere in the numerator with anywhere in the denominator. So this x and this x become 1. This 8 and that 8 become 1. 6 and 10 share a common factor of 2. And what I'm left with is 5/3x squared. There are no common factors between 5 and 3, and so I'm done. Now, don't forget, every whole number can be written over 1. So I'm really talking about 4 times 2 in my numerator and 1 times 10n squared in my denominator. We cancel. I see that 2 and 10 share a common factor of 2. And so I have 4/5n squared as my final answer. Now those are some pretty straightforward examples, but what happens when we need to start factoring a little bit to make our answers work out? So first thing we always look for is greatest common factor. So between 5b cubed minus 50b squared, my greatest common factor is 5b squared. When I divide that out, I'm left with b minus 10. 2b minus 5 can't be factored. b minus 1 can't be factored, but 10b cubed plus 25b squared does have a greatest common factor of 5b squared. When I take that out, I have 2b plus 5. Now, for the sake of clarity and not losing anything in my messiness, I'm going to rewrite it. So I have 5b squared times b minus 10 times 2b plus 5 all over b minus 1 times 5b squared times 2b plus 5. Since I have a string of multiplication, I'm free to start canceling. 5b squared divided by 5b squared is 1. 2b plus 5 divided by 2b plus 5 is 1. And I am left with b minus 10 over b minus 1. Now it's tempting to want to cancel those b's and end up with negative 10 over negative 1, which is 10. But let's let b equal 3 for just a random value and say 3 minus 10 over 3 minus 1 would be negative 7 over 2, which certainly is not the same thing as 10. So when you start thinking about actually putting a value in for that variable, you can see why we can't cancel it. Now this last one does look like a big ugly, but if you take each piece and look for greatest common factors and trial and error factoring and break it down into its pieces, it's really not that bad. So first order of business, greatest common factor. This first number has a 10x squared as the greatest common factor. So that one is simplified. 3x squared plus 39x plus 90 has a greatest common factor of 3. When I take that out, I still have a trinomial that I'm going to have to come back and factor. 6x squared minus 3x minus 63 has a greatest common factor of 3. And when I take that out, I still have a trinomial I'm going to have to come back to factor, and x minus 2 can't be simplified. Now I'm going to go ahead and keep factoring. So my 10x squared times 2x minus 7 can't be changed. My 3 is simplified, but now this part, and I'm going to color code this for you, this trinomial needs to be broken down into its two factors. So I have an x in each side, plus factors of 30 that will make 13, 1 and 30, 2 and 15, 3 and 10, 5 and 6, clearly 3 and 10. Now I have a similar thing going on in the bottom. I have 3, and now this trinomial right here has to become its factors, and the x minus 2 will just carry down. I'm not simplifying anything yet, I'm just factoring. Now, what are the factors of 2 that are going to combine with the factors of 27, x plus, x minus, so that I get a minus 1 in the middle? Run through your combinations. Pretty clear, if I have 6 minus 7, I'll get a minus 1. So I want a minus 7, and I need a positive 6, and so that is now factored. Now, once I look at this, I can begin looking for those common factors that I can cross off. The 3 and the 3 cancel. X plus 3 cancels with x plus 3. 2x minus 7 cancels with 2x minus 7, and I'm left with 10x squared times x plus 10 all over x minus 2. That is my final answer. And that's all there is to multiply. Now, dividing really doesn't add anything new to the problem except the reciprocal step. Once you make that reciprocal step, you are back to multiplication. Remember, it's always the second fraction, and then we're going to flip and factor. Here's my second fraction. So I have 5p squared over 6 times 8 over 7p cubed. Once I've turned it into that multiplication problem, it's just like the previous examples. P squared and p cubed will cancel, leaving p. 6 and 8 will cancel, leaving 4 and 3. And that leaves me 20 over 21p. I don't have any common factors, and I'm done. It's tempting to want to cancel here first, and it would technically be correct. I always wait until after I flip just to prevent making a silly, careless error. So I'm going to write 8x squared times 8 is going to be 8x times 7x. Now that I've flipped and I'm all to multiplication, I'm free to cancel. I'm going to cancel that 8 and that 8. I have 2 x's in my numerator, which will cancel with my 2 x's in the denominator. And I'm left with a nice, neat, tidy 8/7. Now don't panic if you get to an example that has a whole number, because remember, every whole number can be written over 1. When I go to flip this, and I'm going to factor this factors, so I'm going to have 2 times a minus 8 times 1 all over 2 times 8a squared. And when you go through and factor, it's a pretty limited factoring, and I have a minus 8 over 8a squared. And again, while it's tempting to want to cancel there, you can't because it will change the numerical value of your problem. This one looks huge and scary. First thing I notice and begin to get suspect about is that perhaps those two are going to cancel when I flip my second fraction. So I'm going to hold off on my factoring until I see what's going on. And so I have 12v squared plus 12v, one number. That's now times 20 minus 70v, all over 7v squared plus 61v minus 18 times 12v squared plus 12v. Now, it's clear that this and this are identical, and so I can cancel them. Now I'm going to get about the business of actually factoring and seeing what else maybe I could cancel. So my numerator has a greatest common factor of 10, so I have 2 minus 7v. My denominator is going to factor into some sort of trinomial with v plus and minus. I need to look at the factors of 7 and how they combine with the factors of 18 to make 61. So I'm subtracting, because remember when I've got my opposite signs, so I start. So 1 times 1 minus 7 times 18. That's not going to work. 1 times 18 minus 7 times 1. That's not going to work. 1 times 2 minus 7 times 9. Bingo, 63 minus 2. Now, I want the 63 to be positive, so that means I need my 7 and 9 to multiply together in a positive way. I'm going to put my 7 here, my 9 here, my 2, and my 1. Quick check, positive 63, negative 2, positive 61. Now, when you look at this, these two guys right here seem awful close to being the same thing. So I think I'm going to pull out a little trick, and I'm going to factor a negative 1 out of this expression right here. When I factor a negative 1 out, it essentially changes the signs. And why I would do that is because now, if you think about rearranging this one right here to 7v minus 2, which is the exact same thing. Now those are the same. I can cancel. Don't lose track of that negative, and I have negative 10 over v plus 9. You can't arbitrarily just switch them because it's not an equality, so you can't switch both sides. You physically have to factor out a negative